Salam and good day, Madam Akmal. Today, me and my group gonna present the database assignment titled Entry Relationship ER Modeling. Before that, let me introduce first to my group members. First, we got me myself, Muhammad Omar Naim bin Muhammad Alias, and then my fellow group mates is Azran Adam bin Jafris, Adam Imtiaz bin Aidillah, and also Faiz Iskandar bin Muhammad Ridwan. Okay, so without further ado, let me pass the mic to Azra Adam so that he can start his explanation on the part 1 introduction.
So for our topic section, we choose entity relationship modeling. Basically, it is just entity relationship diagram is a visual representation of entities and the relationships between them. So the learning outcome of the topic is database troubleshooting. ER diagrams are used to analyze existing databases to find and resolve problems in logic or deployment. Drawing the diagram should reveal where it's going wrong. Business information systems. The diagrams are used to design or analyze relational databases used in business processes. Any business process that uses field data involving entities, actions, and interplay can potentially benefit from a relational database. It can streamline processes, uncover information more easily, and improve results. After that, business process re-engineering, BPR, ER diagram help in analyzing databases used in business process re-engineering and in modeling a new database setup. Okay, the next one is education. Databases are today's method of storing relational information for educational purposes and later retrieval. So ER diagrams can be valuable in planning those data structures. After that, research. Since so much research focuses on structured data, ER diagrams can play a key role in setting up useful databases to analyze the data. Lastly, database design. ER diagrams are used to model and design relational databases in terms of logic and business rules, and in terms of the specific technology to be implemented in software engineering. An ER diagram is often an initial in determining requirements for an information systems project. It's also used to model a particular database or databases. A relational database has an equivalent relational table and can potentially be expressed that way as needed. Okay, I'll pass the part 2 to Adam Imtiaz.
So the part two is database concept explanation. Entity relationship model or AR modeling is a graphical approach to database design. It is a high-level data model that defines data elements and their relationship for a specific software system. An ER model is used to represent real-world objects. An entity is a thing or object in the real world that is distinguishable from the surroundings environment. For example, each employee of an organization is a separate entity, following a sum of the major characteristic of entities. So the characteristic of a relational table is first, value are atomic. Second, all of the values in a column have the same data type. Next, each row is unique. Next, the sequence of columns is insignificant. The sequence of rows is insignificant. Each column has a unique name, and the integrity constraints maintain data consistency across multiple tables. I'll pass the mic to Omar.
Okay, thank you, Adam, for that lovely explanation. Let me continue. So then we have two types of keys. First, we have entity keys, and second, we have candidate keys. Let me explain entity keys first. So entity keys refers to an attribute that uniquely defines an entity in an entity set. Entity keys can be super, candidate, or primary. Super key. Super key is a set of attributes, one or more, that together define an entity in an entity set. And then candidate key. Candidate key is a minimal super key, meaning it has the least possible number of attributes to still be a super key. An entity set may have more than one candidate key. And then we have primary key. Primary key is a candidate key chosen by the database designer to uniquely identify the entity set. And then lastly, we have foreign key. Foreign key identifies the relationship between entities. And then after that, we have dependencies. A dependency describes the relationship among activities and specifies the particular order in which they need to be performed. And then dependencies arise in every decision making, planning, and developing process and are ideally predetermined. And then tasks can be successors and predecessors to other tasks whereby the instant of each execution may be aligned accordingly. And then we have example of dependencies. First, we have finish to start dependency, and then finish to finish dependency, and then start to start dependency, and then start to finish dependency. And then we have integrity rules. There are two types of integrity mentioned in integrity rules, entity and reference. And then we have entity integrity ensures that each primary key in a table has a unique value. So each row is uniquely identified. A primary key must not have a null value. This provides each row with a unique identity and allows foreign key values to reference primary key values. And then we have reference integrity ensures that a foreign key values refers to an existing row in another relation. It prevents deleting a row in one table with mandatory matching foreign key values in another table. Okay, so that's the end of part 2. Let me pass the mic to Iskandar so that he can explain part 3.
Thank you, Adam and Omar, for the first mention about part 2. And now I'm going to explain about part 3. What is an ER diagram? ER diagram is an entity relationship diagram, also known as ERD, ER diagram, or ER model. It's a type of structural diagram for use in database design. An ERD contains different symbols and connectors that visualize two important pieces of information. The major entities within the system scope and the relationships among these entities. What is the ERD entity? It refers to the entity set and not to a single entity occurrence. For attribute, characteristics of entities. For required attribute, it must have a value and cannot be left empty. For optional attribute, does not require a value, can be left empty. For domain, set of possible values for a given attribute. For identifiers, one or more attributes that uniquely identify each entity instance. For multi-value attributes that have many values and require creating. For the second one, several new attributes, one for each component of the original multi-valued attribute. The last, a new entity composed of the original multi-valued attributes components. And then derived attribute whose value is calculated from other attributes. And lastly, for relationship, is association between entities that always operate in both directions. And participants, entities that participate in a relationship. For connectivity, describes the relationship classification. And lastly, for cardinality, expresses the minimum and maximum number for entity occurrences associated with one occurrence for of related entity. Now I'm going to show you the basic relationship with two examples, each using chain or cross food model. This is one to many. If you can see, customer and one person and many to order, many customer. Just like you order, such that a customer always want to order so many things and not the one thing. That's what you call one to many. And then student, as student, we not learn we not learn one subject in school, but we learn many subjects in the school. That's why we use student one to many subjects. And then it is many to many. As you can see, this employee that learn skill. For employee, we must learn many skill to get experiences for the future. That's why we call many to many. And for student, we call student many to student organization because student have many categories, so that's why we call many to many for student organization. And this is one to one. One employee manage one department. As you can see in the office, not all employee in one department, but one employee manage one department because it hard to handle with many teams. And last one is for professor. Professor is such a level high education. That's why professor one choice for department, so he can handle with his department. This is a question and solution. That you can see this table name products, table name customers, and table name orders. As you can see, it's a relationship that we have to customers. All customers must have customer ID. So the orders can track which customer's ID must have name, address, email, and phone. This was the one to many. And then you have orders. Order also must have order ID, customer ID, product ID, quantity, total price, and order date. This is must record in databases already record for every customer that orders in the online. This is called many to many. And then you have the products policy. All products must include the product ID, name, quantity, type, and price. This is because customer orders for the product and the product has many type and quantity. That's why we have this business rules for the existing to record in the database. I think that's all for the part 3. Thank you and see you again.
So that's it for our group. I hope Madam and anyone who watch this video will understand our topic and will benefit from it. Thank you and see you later. Bye.